Hello folks, welcome once again. In this video, I'm going to build our image caption model containing embedding, dropout, dense and LSTM layers for handling the text input sequences. We will also utilize image features generated using VGG16 model as an input so that model can be trained on the basis of these two inputs, the text sequences as well as image features. If you remember, we restructured this VGG16 model in the previous video, right? So you can watch that video to get the complete details. Finally, we will then be merging these two inputs, the text sequences as well as image features, to predict these captions from the images, right? So watch this video till the end to understand the heart and soul of this project. Folks, this is Nitin welcoming you to the AI University channel where you can learn all your favorite digital technologies like machine learning, deep learning, AI, big data, Hadoop, virtual reality, and cloud computing. You can acquire the related skill sets in order to advance your career in these fields. This channel takes on hands-on approach to build AI-based products and applications. So if you are new to this channel, then consider subscribing to it. Or if you have already subscribed, then click on the bell icon to receive the notifications about the hottest technologies of 21st century. So let's depict our image caption model through a diagram. Here, the box represented by RNN/LSTM is a sequence processor which actually uses an embedding layer, which is kind of a word representation which allows words with similar meaning to have similar representation, that is, identifying the context of the words. Using word embeddings, words can be represented in the form of real value vectors. If you want to know more about word embedding, then you can watch the video in the I button above. We also utilized the LSTM layer to process this text data, which is now in vector form after it passed through embedding layer in order to preserve the sequence information of text and find out the correlation among the different word features. You can watch the video in the I button above to know more about LSTM models. Then we have VGG16 model, which is pre-trained model and which we actually utilized to extract image features by popping off the output layer. So it took image as an input and gave image features as an output. Okay. Now both image feature extractor and sequence processor output, which spit out a fixed length output vector, are merged together and processed by a dense layer in order to predict the captions. So let's quickly move on to the code related to building an image caption deep learning models. So we will create a Python function here which will house the entire structure of our image caption model, right? So let me open my Jupyter notebook real quickly. So here is the function called define model. Okay, as you can see here, and this function basically takes vocabulary size and maximum length of a description as an input argument, as you can see here, right? And here first we are creating the image feature extractor model, which takes input in the form of a vector containing 4096 elements. We are basically utilizing input class of keras.layer library, okay, in order to do that. So if I scroll up, you can see here, right? So this particular library, this class, input class, okay. So I'm using that input class here. Hence this model expects input image feature to be a vector of 4096 elements. Then we are utilizing a dropout layer for regularization, as you can see here, right? For regularization, which is basically used to reduce the overfitting of the training data set. We can perform this regularization by doing 50% dropout, and which is depicted by this 0.5 value, meaning 50% dropout. Then we are using dense layer here, right, to process 4096 elements of input layer above, thereby producing 256 element representation of an image, right, as you can see here, right. Please note that I'm using activation function as a ReLU or rectifier linear unit here, okay. And if you want to know more about activation functions, then watch the video given in the I button above. Next model is a sequence processing model, which is this one, okay, which takes input descriptions or sentences as an input in order to be fed to the embedding layer, which is this layer, okay. The input sentences or sequences are of length 34 words, okay, and the mask 0 parameter here I have kept it as true, okay, and it is kept as true in order to ignore the padded values, okay. Next we are utilizing again the dropout layer, as you can see here, to cater overfitting by doing 50% dropout, right. Next we are using LSTM layer having 256 memory units, as you can see here, right, to process these text descriptions of the sentences, right. The decoding model, which is this one, okay, this decoding model then merges the vectors from both of the input model defined above by doing an addition operation, as you can see here, the add operation, right. Next we are utilizing a dense or fully connected layer, okay, with 250 memory units and ReLU activation functions, right, as well as a final output dense layer to predict next word in the sequence or sentence. Please note that the output dense layer makes use of softmax function to provide prediction using the entire vocabulary size depicted by vocab_size parameter. Next we are trying all the image features and word sequences using the model class of keras.layers library, okay. And as you can see, the loss function used here is categorical _cross entropy, and optimizer is Adam, okay. And if you want to know more about the loss functions, then click on the I button above in order to get the complete details around that. Next I'm printing the summary of the model, okay, as well as returning the model from this function here, right. So folks, this is it for this video. To conclude, we developed the image caption deep learning model function in this video. I explained each and every component of it, and in the next video we are going to see how to fit this model. So let me ask you a question from today's video. Why do we use dropout layer in our image caption model? Please post your comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also ask your technical questions in the comment section. I will be glad to answer your questions. If you're watching this video and you're not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming videos, so keep on watching. Thank you.